Respected Chief Guest, Mr. Arif Mohamed Khan, Principal of the College, Dr. Mohamed Meeran, Head of the Department, Thasleen Fathima, staff members of the Department of Information Technology, and all the participants. I, K. Isaac Faisal, host of the event, with my co-host, Mr. A.K. Janardhanan, welcome everyone to the today's webinar on understanding artificial neural networks. Before going to the webinar, I want to say a few words about the founder of our institution. There was a time in which the people of Kambam Valley had hard times in getting the good education to serve the poor people and for their upliftment. The visionary leader of Kambam Valley, Haji S. Mohamed Meeran alias Karutarautar, started this institution in 1956. I feel proud that our college has been functioning around more than 60 years and continues its effort to eradicate illiteracy in the Kambam Valley. Next, I want to introduce the chief guest, Mr. Arif Mohamed Khan. He got his master's degree in mechatronics at Madras Institute of Technology. He was part of many research projects while working in Rajalakshmi Engineering College, Chennai. He always had passion towards teaching but bored with old traditional method. He felt that practical aspect of a subject is important for a learner to gain sound knowledge in the particular subject. With this in mind, he gave up his career and started an institute called Tarcin Robotics to pursue his dream. Now, without taking further time, I am concluding my speech and handing over the control to the chief guest. Participants can post their queries regarding the webinar in the live chat. The link to the feedback form will be given around 11:50 a.m. in the live chat and will be open for 2 hours.
Okay. Good
Okay.
morning. Yeah. Okay. Well, good morning. Myself, I'm Arif here, and I'm going to present today about neural networks. Okay. So before going to the topic, I'll tell you where neural networks are being used, and neural networks are being used in health industry, and it is also used in bank industry, and for research purpose, and uh, there is no such an area where we cannot implement artificial neural networks into it. And a typical typical example is we can train a neural network model to gain uh, to gain its we can train a neural network model to gain its what do you call to get training in healthcare industry, and we can use it as a we can use this for a second opinion of for asking second opinion in the health industry market. Okay, I'll go to the topic now. Okay, and so let's get to the topic, and it is about the introduction of neural networks. I think so there's been a lag between my audio and video. Kindly cooperate with it. So today our main agenda is about understanding artificial neural networks. So that is what we are going to see towards it. And I'm able to see your comments at the YouTube channel. I'll be also happy to answer any of your queries present into it as of now. You can also post your queries in YouTube channel. I'll also have a look at it. And in case if I'm unable to answer your question, have a note of it. And at the final last 15 minutes, you'll be provided an opportunity to interact with me, and I will be also happy to answer all your questions. So let's go to the topic. And our main topics today is machine learning and neural networks. So let's get started. So what is machine learning and what it has to do with neural networks? So there are two definitions for machine learnings that are being offered. First one is the traditional one, which defines that the field of a study that gives the computer the ability to learn without being explicitly programmed. This is an informal definition given, and the new definition is it is a computer program which is set to learn from an experience with respect to task and performance measure. If its performance measure at its task is measured by P, it improves experience. This is what is machine learning about, and what it has to do with neural networks. So machine learning is the base of all the artificial intelligence models working in today's scenario. So from machine learning is one of the artificial neural networks is one of the method used in machine learning, and so machine learning is nothing but it is an ability to make a machine or a computer to learn by itself, and then to do a task, and then by evaluating the performance it has done, we can set it as an automated task where there is no human interventions happening around it. So I hope you understood what is machine learning. So next is we'll go for a typical example. It is like playing chess. uh, so how do we play chess? Everyone thinks chess is a game of skills and knowledge, but that is not how it is. Chess is a typical example for what do you call as a game of experience, not a game of skill or something. So the more number of games you play in chess, the more chances are there for you to win. So that is how the basic principle of chess is working. So for playing chess, you need of experience of playing many chess, and then while applying all this experience into a new game, you will get the probability of either winning or losing the match. So when you have a lot of experience, you have the higher probability of winning the next game. So this is what typical machine learning is all about. You learn something, you redefine something, and then you apply it, and then you evaluate the performance of it. So this is how all of the artificial intelligence works in a day-to-day scenario. So there are two basics things into it. One is supervised and unsupervised learning. So we'll go with supervised learning as of now. Supervised learning is all about labeling the data to evaluate its accuracy on training data. And supervised learning problems are categorized into regression and classifications. So we'll see what is regression in upcoming slides. So this is what is all about supervised learning. In short term, supervised learning is about uh, if you know the input and output, you can get the training model done in supervised learning. For example, if there are three balls and I need to pick the red ball, I need the output of a red ball, and I have three balls, which is red, green, and blue. So I have my input and I have my output. The only criteria is how am I going to select the red ball or green ball or yellow ball. So I have to train some data into it, and then by modeling all those data, I'll be able to get my required ball from the training model. So this is what is all about supervised learning. In short, it is that if you have an input and if you know the input and output, you can very well apply the model into a supervised learning. In an unsupervised learning, in an unsupervised model, it is a contrast of supervised model. It provides unlabeled data that the algorithms try to make sense of, extracting features and patterns on its own. And we can derive the structure by clustering the data based on the relationships among the variables in data. This is nothing but say in the previous example we know what is we knew what is the input and output of it. We had three balls and we have to select one ball. In a case, I don't know how many balls are present in there, and I don't know how many balls I have to take. So what I'll do is I'll just put it into my unsupervised learning, and I'll get my I'll just put I'll just train my model to get two balls of different colors, either green, blue, or something. But I don't know the exact number of inputs. I don't know how many red balls are there. I don't know how many green balls are there. How many blue balls are there? How many different color of balls are there? And I don't know how it's going to take into it. But I know the training model, so I'll give it to an unsupervised learning, and now the computer will be able to make its own decision. In the previous scenario, I have to teach the computer like a kid. So I'll have to teach him how to select a red ball, green ball, and blue ball, and based on my teaching, he will be able to take it. Whereas here, I don't know the input and output, so the computer, based on the previous experience, and or else based on the learning by itself. Uh, so based on the learning by itself, it will be able to derive the desired output. So this is what is unsupervised learning is all about. And so model representation. So this is nothing but this is how the entire I hope you're able to see my mouse. Okay, even if it's not visible, it's fine. Okay, fine, it's fine. So model representation is nothing but how you're going to train the model in a the model in a particular way. So this is how all of the artificial intelligence models work. You have a certain input, and you need a desired output. Okay, and this will be your training model, and above that you have your learning algorithms, and then your training set. So to give you a to give you a real world example, this will be my balls, that is my grid ball, and this will be my uh, desired red color balls. So that is what it is all about. So in order to extract in order to work this model, we need some training data set. That is, we need to train the computer about green ball, blue ball, and red ball, and we need to apply the learning algorithms over here. The learning algorithms or artificial neural networks is one of it, and then we have support vector machine, and we have genetic algorithm, and then we have around 8 algorithms present into it. And we are going to see a particular learning algorithm here. Today is artificial neural networks, and so this is how the model is represented for training, to do a training. Okay, so I hope you know what is gradient descendant. It is also known as the steppers descent, is used to accurately present the minimum cost function with the least number of errors on given on a data set. So I hope you all know what is gradient descent. If not, I'll give you a small example. See, if a driver is going on a slope which is inclined towards downwards, and he has to reach a particular from here, I think so. My post pointer is working. From here to here, the driver needs to reach through a slope. So the driver is unaware, and he's unaware of the routes, and he also doesn't know how to reach the desired location. He may end up moving from here to here, here to here, here to here, and here to here. So there is some oscillation to make some decisions into it. So what he can do is he can either go from a point to point, that is from 1, 2, 3, 4, like this, and he reach the desired position. This is what gradient descent is all about. So you need to represent with a minimum cost function with the least number of errors on given data set, so that the driver can reach the desired position with the least number of errors into it. So regression, and I hope so everyone knows what is regression. You should have learned in mathematics. And linear regression is a basic and commonly used type for predictive analysis. uh, Linear regression is a special case of regression analysis which try to explain the relationship between a dependent variable, one or more on explanatory variables. See, if I have a data set like this, I will be able to make some decisions into it. You'll have a chart as of now. Yeah. So if I have a data set like this, I'll be able to get a linear model into it. So this is what linear regression is all about. So next is classification. So as the name defines, classification is nothing but classifying each product, each product or each data based on their category. For example, if you have a group of flowers, you can classify them based on their sepals and petals. Or else, if you have a number of cricket balls, you can classify them based on their colors, red or white. So that is what classification is all about. So why do we need to classification is mainly used for reducing the number of data sets. When we classify, we can take the data which is required for us. For example, this is a typical example for measuring the tumor size of a human. So as you can see here, if there is no tumor, you will have this points here, and if there is tumors present, you will have your points over there. And we'll have a certain threshold which is 0.5, and if the values crosses the threshold, you will have a S, and if the value comes below zero, sorry, comes below the threshold, you will have a value, you'll have a prediction of 0. So that is what it is all about. And these are the examples for some typical examples for classification. You can classify an email whether it is a spam or not. You can see whether an online transaction which has been done fraudulent or not. You can see a tumor whether it is malignant or benign. So 0 is a negative case, and it can be categorized as 1 as a positive case. So how does our algorithm classify? It's done using logistic regression. So there is a typical example between linear and a logistic regression. Logistic regression does not try to predict the value of a numerical variable. Instead, what it does is it it predicts the output. Um, so it's like in guessing and game. It's like guessing the number. If I give you a set of 10 digits from 0 to 1, and if I ask you to predict a number, you'll use logistic regression for it. You will either go for, first you will ask me a question whether it is from 1 to 5 or 6 to 10. That is how you ask me, and from that you'll ask me whether it is an even or odd, and then you'll ask me whether it is from 7, between 7 or above, between 7 and 10. So like that, and we'll be able to get our number. So the same principle works here on for logistic regression. That is what it does. It does not predict the value of a numerical by giving the set of inputs. But previously, logistic regression uses the values which are being already provided as input, and then we'll get an output. So I hope you understand this. So this is the difference between unsupervised and the supervised learning. Whereas previously you had an input and also you know what is the output. Whereas here you don't know the input. You have some inputs, but you don't know which is the input, and also you don't know what is the output you which will come into it. So under such scenarios, we can use logistic regression into it. So this is a typical example, same example of it, which is h naught x estimated probability. That is estimated probability that why you'll get a tumor size. Okay, so if I get this value 0.7, then there are chances that the has some patient has a tumor into it. So this is how logistic regressions work into it. I hope this is understandable. I'll go to the next slide. So what we have, more classes. For example, previously I told we have only previously we I told you that flowers are classified based on the sepals and petals. Now we have flowers and the person who is going to pick it and where the flowers are placed, and how the flowers are going. So like that, email classification, work, friends, family, hobby, those kind of things. You see a typical example here. You see a self-driving car, and a self-driving car has a variety of sensors, and these sensors will get some information from it. For example, we'll get information from a sensor where the light is traffic light is green or red. Also we'll get the speed limit of it, and we'll see the front and back objects. These informations will be passed to a neural network. Yeah, so those things will be passed to a typical neural network, and then we'll get a desired output for it, whether we have to drive or to stop. Okay, so this is what this is what inside a typical neural network model. So can you see there is these are the things which is called as neurons. So this thing here is called as these thing is called as one layer, and two layers, three layers, and four layers. These layers will be interconnected to get a desired output. Yeah. See, so what happens is it is interconnected between them through a weighted connection. Okay, they are all interconnected through weighted connection. So while taking two typical nodes of a neural network, you will get two weights for it. There is one weight here and the other weight here. So based on the weight which we get, yeah. So a neuron gets its value, and then it multiplies with the weighted average, and then sorry, in your it multiplies with the weight, and then it adds the both the values received from it, and then we have some bias so that the network does not gets delayed, or it does not get stuck into it. After doing this process, we have something called as activation function, which is for activating the neurons to work. Now we got a value for it. We have applied the formula, and we have got a value for it, and transferring it to another neuron. So from here to here, the entire sequence will operate in the same manner. This is how artificial neural networks actually works. But the problem is we need to know the right values for it. We need to know the right values and variables in order to get our desired output. Okay, so I'll go to the next slide. So how does it learn and how does it get trained? How it is trained? For this, we'll actually see two examples. One is about reading number of digits, and then about classifying email whether it is a spam or not. Okay, so this is what we have shown in a video. You'll have some input layers, and you'll have an hidden layers, and then you'll get an output layer. So these are your training sets. You have some inputs and outputs, and this is a supervised learning. So I know my input and output. I'll give my inputs here so that uh, this data can be transferred to this hidden layer where all the operations where you've seen previously, you'll get an activation function, you will have a bias, and I have some input data here, which is my zeros and ones. My input layer is here, which is 0, and this will get transferred to here. Now it will be 0, and this will have a so you saw, right, some weighted values. For example, say 0, and then these two will get multiplied, and then it will be transferred here. So 0 into 0 is nothing but, which is nothing but 0, and this will get transferred again here, and this will get transferred again here, and I'll get my output as 0. Whereas here I'm adding 1, and 0 to 0 it is 0, and then I'm again getting a 0 here, and I'm sending this value to here, and again I'm getting 0 here, and now I'm adding some bias to it, which is 0.5. So 0 plus 0.5 is 0.5, and again I'm adding some bias to it. I'm getting 1 here, and then I'm getting my resultant as 1 here. So this is how entire neural network model works. Okay, so you see there, right, which is nothing but you have two inputs, 1 and 1, and this will be transferred to some hidden neural networks, and you'll get some desired output over there. You'll have to add some weight. You see the right, 1, 0.8, 0.4, 0.2, and this gets sums into it, and we need to activate the unit from this layer, and then using the sigmoid logistic function, we can transform zeros and ones, and we can get the desired output. So this is the mathematics and functions which are being working around behind the neural motor. So target is 0, and our calculated value is 0.7. So we can minimize the error by having a margin of 0.077. Then by minimizing it, we'll get our desired output, and these are the mathematical operations which are happening behind. These are the mathematical scenarios which are being happening behind the computational regions, and then we get our calculated value as 0.69, whereas our desired is 0. So I hope you understand the previous concept. So now we are going to see how we can get a data to get the values of handwritten. So you can see here, right, these are all handwritten digits, and our task is to make the system understand how what are the numbers being offered by this solution. Okay, so for this we need to train the data, and these are our programming codes, and this is the output which we got for it. I hope so it is visible. This program runs the iteration for every training data so that the error margin is minimized. So we have already seen our error margin previously, and this was my training accuracy. As I have told you previously, what we are doing is we are doing a supervised learning. So we have to teach the neural networks like a kid. So and I just got a accuracy of 94, and then I have to test my prediction, and I have displayed an image, and it has predicted me exactly what is the number of it. So this is how we have to do it. Okay, so how predictive model works, how we are making predictive models working. Okay, first we have to choose the data, and then we have to transform it, analyze it, create a predictive model, train train the model, and we have to get our end result. Okay, so for this we need zeros and ones, and the zeros and ones will be segregated as zeros and ones, and then we need to read the data. Analyze is nothing but we need to read those data, and then create a predictive model, which is nothing but a neural model, neural networks, or else we need some models to it, logistic regression, or what is it, linear regression or logistic regression. You need some models for creating a for creating a prediction, and then you need to train the models using some algorithms which are present in machine learning, such as support vector neural networks, and many other genetic algorithms. There are 8 to 10 algorithms present in machine learning, and then we'll get our end result here. So this is how a typical artificial intelligence model works. Okay, so with this, the topic has been
Now
concluded.
I call Mr. A.K. Janardhanan, co-host of the event, to deliver the vote of thanks.
Good afternoon to all. First of all, I thanks to God to give this opportunity. I am A.K. Janardhanan, Assistant Professor of and co-host of the event. On behalf of the PG Department of Information Technology, Haji Kartaravtar Houdia College, I would like to thank the resource person, Mr. Arif Mohamed Khan, CEO and co-founder, Tarcin Robotics, for gracing today's webinar and making this webinar interesting as well as meaningful. I would like to express our gratitude to the principal, secretary and correspondent, college governing committee for their support and encouragement. I would also like to thank our HOD, J. Thasleen Fathima, and coordinator of the event, G. Manonmani, for their moral support and guidance. I am happy to express my thanks to this event organizer, C. Sheik Mydeen, host of the event, K. Isaac Faisal, LMS coordinator, Abu Bakr Siddiq, for giving shape to this event. Last but not least, a very big thanks to all the participants for joining us and making this event successful. Once again, I thank everyone for the cordial cooperation. Thank you all.